Hey guys, so today let's take a look at Cobalt Strike Beacons and what the structure looks like for those and how to parse them out. Depending on how you find the beacon, there'll be a couple different ways that it'll look. The first one is if it's staged on an external site or directly within some sort of dropped code, it's going to be XORed with known byte values. You can see here that version 3 is 0x69 and version 4 is 0x2e. The second way would be if you dumped it from memory. In that case, it's going to be XORed with the byte above, but also encrypted with an unknown 4-byte hex value. So the quickest way to see what you're dealing with is use the Hex Editor and look for the start of the beacon with any of these. So you can look for a 2E2F sequence for a version 4 and a 6968 sequence for a version 3. If you're already dealing with a beacon that's been decoded, it's going to start with a 0001, 0001, 0002. All right, so let's look at the actual format. So Cobalt Strike Beacons use what's called a TLV binary structure. So it's going to be type length value binary structure. In this case, it's index number, type length value. The type is either OX1 for short, OX2 for int, OX3 for byte array or a blob. So once you find the start of the beacon, you can use this to parse each section by hand if you wanted to. So there's an example below. You can see we have a 0001, 0001, 0002. So in this case, 0001 is the index, number 1. 0001 is the type, short. 0002 is the length. And then the value follows that for that length, which is 0, which is a HTTP beacon. In this one, it's an index 8 and has a type 3, which is a byte array. So the length is OX100 here. And you can see if we follow that for this length, that's going to be our actual value stored there. Okay, these are nice on the slides, but let's actually take a look at a real one and see if we can go ahead and parse this out. So we have a DLL here, and we don't really know what we have. So let's pull it over to a hex editor and take a quick look. Let's search for those known values that we just talked about. So let's search for the 2E2F. No hits for that. So it's not a V4 beacon. Let's take a look and see if it's a V3 beacon. And we do have a hit for that. So you can see 6968, 6968. This would be the start of where the version 3 beacon is. So we need to decrypt that. Now, SentinelOne has an excellent tool written in Python that will go ahead and parse these for you, and it'll decrypt them for you, and it'll go ahead and print out all the values that you see. So it's great. The issue I ran into a few times is if you're on a Windows machine and you don't have Python, or you don't have the required modules for Python in some sort of isolated environment, it's really hard to use that tool. So I wrote one in PowerShell, and the problem with writing these in PowerShell is PowerShell doesn't have a native way to parse out file header structure where Python has a module for that. So it's a little longer than need be, but basically it's just what we were talking about. When we look at the file, we try to do a pattern match, and we try to match on the 2E2F, 2E2F that we just looked at for version 4. And we also tried to match on the 6968, 6968 that we also saw for version 3. Now, this portion here is all about parsing out the file headers. Like I said, PowerShell doesn't have a native way to do that, so you have to do it this way. In addition, if it's dumped from memory, then we also have to decrypt it. So it's going to be an XOR key, 4 bytes in length. We know that is a fixed value. So what we can do is we can do pattern matching, and we can go through the entire file 4 bytes at a time, and we can go through the entire data section 4 bytes at a time, and we'll look for these patterns, and we'll store those, and we'll look for the one with the most hits, and that's probably going to be our key. So we can more or less brute force the key this way if we find one in memory, and then we can go ahead and write out the file if we want to. So let's see what that looks like. So we have our beacon test. We're giving it our DLL. And you can see this is a confirmed, non-encrypted Cobalt Strike Beacon version 3. So if we want to write that out to a new file, which we do, it's going to be write file on the end here. And then you can see that it's XORed it with the key OX69, and it saved it with a .out extension. So let's go see what we have. By the way, I'll go ahead and put a link to this PowerShell in the video description. All right, so taking a look at our .out file. So based on our slide here, we should be able to find the start with these values. So let's see if we can do that. And here's the start of our beacon. So if we remember on our slide, we were looking at index number 8. You can see it here, index number 8 with a type value of 3, which is a blob, and it goes for 100. So let's see what that would be. We're going to be looking for 9, and the next section down be here. There's our length 100. If we took a look at index number 9 here, so here's 9, also has a type value of 3, and it's going to go for 80. So let's see what this is. Let's go 80. Okay. And it looks like we have a user agent. Here's our next one, 10, and it is also 3 with a length of 40. And there is our 40. So we can see that we can parse through this by hand. However, like I mentioned before, the SentinelOne tool does a very good job of extracting that information for you. This PowerShell script is more or less to test whether you have a beacon that you might have dumped or you found, and let you decode it so you can take a look at it quickly. If you wanted to parse it out, we can look over here, and you can see that we have an HTTP beacon running on port 4444. The C2 server is the IP address that we saw before, and the user agent is one we saw before. Also, we see the HTTP post URI, and we saw that here as well as number 10. So everything matches up with what we saw. This does a really nice job of printing it out for you so you're not doing the entire thing by hand. So I think that pretty much covers parsing out Cobalt Strike Beacon configs. Next time we might take a look at something from Bishop Box, which is slowly starting to replace those, just mostly for the fact that Cobalt Strike is a paid tool. Sliver is a free tool written in Go. So we might take a look at that next time, but we'll see.